first presenter. Rebecca is an Android programmer, is interested in IoT, and also the Lego fan, as I heard. And Rebecca, it's yours.
Cool, thank you. Okay, hello everyone. I'm so excited to be here in Prague for my first time. It's a very beautiful city, just a little bit too cold for my likings. So today I'm going to be speaking about Android Things and how you can build a connected product using Android Things. So has anyone touched or used Android Things yet? Okay, a few people. Okay, so for you, intro part is going to be a little bit boring, but for everyone else, you'll learn a little bit about Android Things. So a little bit of information about me. I traveled and I live in South Africa. The sound is really bad. Hello? Okay, so I'm from South Africa, Johannesburg, South Africa. Anyone been there? No? Oh my goodness. Okay, hopefully I can convince some of you to venture down into Africa. So you can find me also online. You can find my blog, rigaroo.co.za online, and I've got a couple of Android Things tutorials as well as just other general Android stuff that you can have a look at. And I work for a company called DVT, which is a custom software solution company based in Johannesburg, South Africa. And I lead up the Android engineering that we do there. So just a little bit of information about me. So today we're going to have a look at 4 different things. So we're first going to have a look at Android Things and what it is. Then we're going to have a look at the Google Assistant, so how you can use the Google Assistant with Android Things or just the Google Assistant Smart Home. And then we'll have a look at a couple of different storage options for you for looking at IoT stuff or just in general some storage options for that. And then we'll have a look at some examples using some of the cool stuff that people have built online using Android Things. So what is Android Things? For those that don't know, Android Things is an extension of the Android platform for IoT and embedded devices. So we've come to know Android on our phones for very many years. And we've also seen Android now put onto our TVs with Android TV. We've also seen it on Android Wear, on our phone, on our watches. But now with Android Things, you can put Android wherever you want to put it. So if you want to build a connected airplane, for instance, you want a media control system that's powered by Android, you can use Android Things to do that. So some examples of where Android Things would really make sense is in the retail industry, where, say, for instance, you wanted to do some smart inventory control, or in the business industry, where you wanted to have some cameras or connected smart meters or access control powered by Android. You can also look at it in the logistics industry, where you would like to do something like some kind of fancy asset tracking or some insane image processing, for instance. But you can also do home security as well, or anything for the connected home. So if you're like me, just a really enthusiastic about building stuff for your house, you can build things such as smart doorbells, routers. That kind of thing works really well for Android Things. So often I get asked the question of how is it similar to normal Android development? And it's very similar in that what you know from becoming or learning about Android, the SDK is very similar on Android Things. So all the things that you're used to using on Android, you can use on Android Things. So for instance, if you wanted to do a background service or some kind of background processing, you can use the Android built-in mechanisms for that. Also, the really great part about developing for Android Things is that you can use Android Studio. So if anyone's done any Arduino development or something like that, you'll know and probably agree with me that developing and using those IDEs are not nearly as nice as using Android Studio. You can also use Play services, so things like the Vision API or barcode scanning, those built-in services provided for you by Android, you can use with Android Things. And then one of my favorites is Firebase. So you can use Firebase to build and make Android Things apps connected to the internet, or a whole bunch of the Firebase stuff that you're used to, you can use with Android Things. And you can use the Google Cloud Platform, so any of the PubSub or those services offered by Google Cloud, you can use with Android things. And because it's just an Android app that you're writing on Android for Android things, you can build using Kotlin, RxJava. If you really like, you can build your Android things apps using that. Okay, so some of the differences with Android things versus normal Android development. The biggest one is that there's no Play Store when you're developing. So the way in which you ship updates to your users is via the OTA console, so the Android Things console. So there's a whole different way in which you manage that. There's also a subset of the APIs available. So for instance, things such as your calendar or contacts, that has been removed in Android Things because it kind of doesn't make sense to have it on a device that is going to be standalone. And then with Android Things, there's custom hardware. So this is one of the big driving parts about doing Android Things, is that you can configure any custom hardware that you want within your app. So for instance, if you wanted to have a custom GPS or you wanted to have a LED strip of lights, you can do that and integrate with that on Android Things. And then I think this is the one that really gets people, and you have to really think about this if you're building for Android Things, is that your app is a single, or your device that you're building is a single purpose device. So you're responsible for shipping the hardware as well as the software. Where traditionally with Android things, with Android, you were developing just the app and going to the Play Store, and your users chose the hardware that they wanted. So because you're now building the hardware, you can control what the hardware has and what apps are installed on it. Okay, so the users don't have access to a Play Store where they can get all the apps that they want. So they can't install those apps that generally give you problems. And then because there's no Play Store, like I did mention earlier, you have to ship OTAs. You have to rather push over-the-air updates instead of app updates. We'll look a little bit at the Android Things console and how you do that in a few slides' time. Okay, so this is the typical software stack of an Android device. So we have our Linux kernel with some of the core parts of Android. We have libraries on top of that provide us with things such as the SQLite, OpenGL, all those libraries on top. And then we have the Android framework, which provides us with things such as the Activity Manager, the Power Manager, Telephone Manager. And then on top of that, we have some pre-built user applications, so things such as your phone, messaging, contacts. Now with Android Things, the application layer is removed. So default apps aren't installed. So you don't have your calendar, your browser. Those are all removed from the system. As well as some key differences in the Android application framework as well. So things such as runtime permissions, which were recently introduced in the newer version of Android, that has been now removed on Android Things. So when your app runs, it runs with the permissions that you've said you want at install time. And also things such as wallpapers and soft keyboards. So if you wanted to ship a keyboard on your Android Things device, you would need to include that separately and manage that yourself. And then on top of this, when you're building for Android Things, you get the Android Things support library. So you get the peripheral I/O, you get user drivers, connectivity, and some device management. We'll go into a little bit more about the peripheral I/O in a few slides. Okay, so why would you choose Android Things versus maybe some other platform? So one of the big differences is that Android Things uses what we call a SOM architecture, or a system on module architecture. Now that means that little device that you see down below contains all the core functionality that Android needs in order to run. So things such as networking, handling all the basic stuff that you don't have to worry about. So Google manages what they call with a Google Managed Board Support package. And during development, you typically have, this is really bad audio. No, it's fine. Okay. So during development of the Android Things application that you're building, you would generally have the board that we see there, and this SOM is placed on top of it, okay? But when you want to go into production, you would typically make a smaller board and not have all the things that are on this board itself. So for instance, if your app doesn't need a networking cable, because some might not, you won't build a board that has that because it is a little bit more costly. So then you can customize it and just use the SOM and customize your board for cheaper development or cheaper production costs. Okay, so when managing and building for Android things, there's a couple of things that are managed by Google and some things that are managed by you as a developer. So Google handles all the difficult parts, I like to call it, so the things such as your Linux kernel, your hardware libraries, and the Android framework. And then you as a developer, you just need to manage the apps, so the APKs that you build, and some user drivers that you might want. So if you want access to a GPS or a specific GPS, you can put that, and you have to manage that on your device. Okay, so taking a quick look at the Android Things console. So the Android Things console allows you to manage your IoT product. So this is where you would typically go and create your product and set certain information about your product on there. It's also where you would download and install the latest version of Android Things for your devices that you're building on. So you can build your factory images and that contain the OEM applications that you want, and then you can, along with the system image, download that and flash it onto the device that you have. And with the Android Things console, this is where you would also push up your OTA updates. So anything that changes, you need to push to the device. You can do this through the Android Things console. And to access it, you can go to partner.android.com/things/console. So a quick little look at what the console looks like. So this is when you've created a product, you would see, for instance, I've created a quick candy dispenser here. And you would select your SOM type. So that, for instance, in my case was the NXP, but can also be, for instance, the Raspberry Pi. And you would choose if you want Google Play services or not. So that will just give you access to more of the Google services for you to use. If you have a look at the factory images tab within the Android Things console, this is where you would create a bundle. So a bundle for Android Things is basically a zip file that contains all the APKs that you want this device to have. So it's very simple. If you just create a folder, put your APK files into it, and zip it up, you can upload it here. You can also include a custom boot animation in your zip file if you wanted to customize it for that purpose. You would also then choose the Android Things version that you want to run for the device, and then from that, it'll build up a custom firmware version for you. You would download that, and then you can flash it onto your device that you have. Then if, for instance, you have devices in the field, so you've now shipped your app and you've got a whole bunch that are running a certain version of your Android Things device, you can create updates and push them through this console on the OTA Updates tab. So what makes this Android Things different from some other kinds of software that you might be using? Something like what we call signed images. So there's a lot of security built into the Android Things console and the Android Things system. So when you're creating OTAs, they're signed, and when the device downloads them, there's a couple of different processes that happen in the background that you don't really need to worry about, but it's important to understand what it gives you as an end user. So things such as verified boot. So that makes sure that when I boot up into a new version of Android Things, it is a verified version of the software that you've got. So it's not downloading or using an old version or corrupted version or a version that's not actually yours. So through a process of verified boot, it allows you to make sure you're running the correct software version. There's also AB rollback protection. So this is built in where now if it has some kind of errors or something wrong with it, it'll automatically switch back to the old version of your app or your operating system on the device. And I think one of the biggest reasons why Android Things is such a compelling option for this is that you get automatic security updates. So for instance, if you don't support or maintain your app anymore, the Android Things console will automatically create versions that you can push to your devices that have security patches. So if you have some really weird form of Android that has some large security hole, the Android Things team will create these patches and ship them to your devices. Okay, so let's have a look at how we can develop for Android Things. So typically, if you want to start developing with it, you would have to acquire a developer kit. So there's a couple on the Android Things website that you can have a look at. My personal favorite is the NXP device. So this is the IMX7D that I've got here. But you can also get a Raspberry Pi 3 if that's a little bit easier for you to access. So the reason why I say the NXP is my favorite is because when you're debugging and deploying, you can do that via a cable, whereas if you're doing it on a Raspberry Pi 3, you need to do that over Wi-Fi. So it's a little bit more tricky to get it connected to the internet and enable and make sure that Android Things works. But it's totally possible to develop on the Raspberry Pi as well. Okay, so for those of you that are not electronics experts like me, who's not an electronics expert, I like to think of it as two different ways in which you can start to access and play around with different peripherals that you might plug into your device. So there's what I like to call the hardware, which is the peripheral I/O, which gives you low-level access to things such as different protocols. So the GPIO protocol, PWM protocol. So this might sound like you don't know what these are. Not to worry, you don't really need to know what they are if you're building for Android Things. That's where the peripheral driver library comes in. So if you go onto GitHub, there is a whole library of different software built for Android Things or drivers, and you get access to things such as a button, so a physical button, a GPS sensor, RGB strip. There's a whole bunch of them that you can get on Android Things GitHub library. So don't freak out if these terms start to sort of, oh my goodness, I don't know, I'm not an electronics expert, what do I do with these? Don't worry about that. I would rather then go directly and use the GitHub libraries that will be a little bit easier to develop with. Okay, so I took some time to investigate and build a motion sensing camera on Android Things. And I just wanted to sort of see how far I could push it in terms of what functionality could I quite easily add without too much effort. So we'll look into a couple of different elements of building a motion sensing camera using Android Things. But there's a full project sample that you can go and have a look at as well if you're interested. Okay, so typically when you're looking at a sample online or some kind of tutorial online, you'll get one of these quite scary looking diagrams that show you how you need to set up your device. So this might be a bit daunting for someone that doesn't have any electronics background, but it's actually quite a simple circuit that we've built here. So we get what we call a breadboard, which is the board right at the bottom, and that allows you to just prototype and create your circuits on it. So you can create a complete circuit using the breadboard. And then all the wires in between just are called jumper wires, and you can then create a complete circuit using the jumper wires. So in this example, I've just got an LED light in the middle there, as well as the motion sensor at the top that is plugged into a few different pins on the board. So something that might, as a software developer, you think it will work, but it doesn't when you do it, is the pins on the board. So if you look at your board that you get all these 40 or so pins on the side of it. Now, as a software developer, I think, oh, look, I can plug in anything to any pin because it works. But actually, the pins mean different things. Okay, so you can't just plug in any pin into anything. You need to double check this before you start plugging in anything. So each board that you get comes with what we call a pinout diagram. Okay, so on the Android Things website, you can head there and there's a whole bunch of information around which pin refers to what. So this is the Pico pinout, and this one gives you an example that the first pin at the top is a 5-volt pin, and then we get to pins that represent GPIO, which is the general purpose input-output. So these kind of sort of match to those protocols that we talked about at the start. So a little bit different. Don't just plug in anything into the device and think it'll work. Double check that you're using the right pins before doing that. As well as just before plugging in anything, this is just a disclaimer, unplug it from power so you don't electrocute yourself. Okay, so how do you create an Android Things project? So if you're using Android Studio 3.0, you can go and say create new Android project. Just give it a name as you would normally create a normal Android app. And then right at the bottom, there's a new option called Android Things. Okay, so you can uncheck the box that says phone and tablet because we're not building for that anymore. And you can select the Android Things option. And then it'll prompt you to create just a blank activity, which we can do. And then what it does is it automatically adds a couple of things into your project. So if you're just building a normal project, you might want to do this yourself. So in your Gradle, build.gradle file, it adds the compile-only dependency, which refers to the Android Things libraries that are already running on your Android Things device. So it also, in your application manifest, in your Android manifest, it adds two things. So the first thing it adds is the fact that it uses the Android Things library, okay? So that just requires and makes sure that when you're running it on a device, this device has the Android Things dependencies already on it. And then on that activity that we created, that default first activity, it adds an intent filter onto it. So this just states to the device that this is the launcher activity for the whole Android Things device. So you need to just add this if you haven't already done it through the normal Android Things create new project process. And what this will do is, say now your device reboots, it'll automatically go and start up this activity by default when you are creating this app. Okay, so how do we work with this motion sensor? So when you're typically dealing with some kind of hardware, you get what we call a data sheet with it. So the data sheet is a lot of information with a lot of diagrams and maybe some confusing stuff, but you have to sort of like weed through that and just find exactly the information that you need in order to develop for your app. So the first thing that we need to know and understand is GPIO. So this is not just specifically for motion sensors, but this is one of the protocols that we talked about at the start. So this is the simplest one that you'll find and probably the easiest one to dive into if you're looking at electronics for the first time. So this stands for General Purpose Input Output, and this allows you to write true or false values to something or read true and false values from something. And so you can use this for things such as turning on an LED, or in our example, we're going to use it for the motion sensor, where we are going to read a true or false value for if motion has been detected or not. Okay, so this is one of the little diagrams that came with the motion sensor. But basically, there's 3 pins on the motion sensor. There's a power pin, there's a ground pin, and then in the middle, there is an input-output pin. Okay, so that's where we're going to read the value true or false from if there's motion detected or not. There's also a couple of other things that we can adjust on this hardware. So we can adjust the sensitivity and the time delay, but that's not really necessary for building your app itself. So that's just a hardware configuration. Okay, so how do we actually do something with it on Android Things? So in your Android Things app, what you would need to do is first define and use the Peripheral Manager service. So this is something that comes with Android Things library. So you would open up the GPIO pin. So that open GPIO is the callback or the method that you would need to use. And then the variable that you give into the method, motion sensor pin, actually refers back to the pin that was defined on the pinout diagram. Okay, so if you remember that, we had a whole bunch of like information. So some of them were like GPIO _ 37. So there's all those different pins that you need to make sure that you're connecting to the right one. And that's exactly where the configuration lies of which pin is giving me the information in or out. So typically, if you're developing for a Raspberry Pi as well as some other device, this you would want to make a configurable value so that you can easily swap them in or out. Okay, so then what we want to do with our GPIO is we want to actually do some stuff. So we want to open and set the direction on it. So this is just to say, when you say direction in, this means that I'm reading from the sensor. I'm not setting values on it. So with the motion sensor, we obviously want to get if there's motion or not. So we would set the direction to in. Okay, but you can also set the active type. So this means that you would get a true value when the reading on the sensor is high, okay? But you can set it to go the other way if you want. So if you wanted to receive a false value for when it's high, you would then change the active type. The next thing that we set is the edge trigger. So this just gives us information of if something has received for when it is high and low. So I would now get a callback when the sensor is on and when it is off. But you can also set this to edge high or edge low if you wanted to just receive one of those events. Okay, and this is where we actually start to get the values. So if we then register the callback in our callback itself, we can get the value of that sensor. Okay, so this will be triggered every single time the sensor picks up a new reading. Okay, and now what we can do is do something with it. So for example, I've got another listener that I do some callbacks on, but I could just turn on an LED at this point. So I could say LED.on or true or false, and just use the value that I've got from the sensor and set the LED to that value. Okay, so let's look a little bit at LED control. So like I mentioned before, with the GPIO protocol that we're using, we get a true or false setting that we can set on the device. So we're going to do the same for an LED. And in this example, I'm doing very similar to the motion sensor, but in this case, I'm setting a value. So I would open up the service, open up the pin that that LED is on the board, and I would set the direction to out this time, because now I am saying I want to set something on it. So I want to set it to true or set it to false. And then I can just say, set the value of it to true, and the LED will come on, or I can set it to false. So I can put this little piece of code into my motion sensor if I wanted to control and make my motion sensor control a little LED. And one important thing to remember is that you need to close up your resources once you finished using them. So you would typically put this in your onDestroy method in your activity, and this will then just allow any other app running on the device, or say for instance you're deploying a different app, it'll allow that app to use that motion sensor or that pin that we've just opened up using the peripheral manager service. Cool. All right, so we've had a brief look at Android things. Hopefully that gets you sort of piqued your interest into looking at how we can use some Android things components and integrations. So we're going to have a quick look at how you can use the Google Assistant with Android things. So in my example, I created a Android things motion sensing camera, but I wanted to be able to somehow control it using my phone. So I wanted to be able to say, okay, Google, turn on the motion alarm, okay? And I wanted it to respond to say, cool, I'm turning it on. Now, it also allows me to turn it off using my voice, which I'm not sure is very secure, because I can just have someone come in and say, hey, turn off the alarm, and it'll be turned off, but we'll get there. So how do we go about doing this? Okay, so if anyone tried the Google Assistant actions on Google, try to make your own one. One person, 2 people, okay, cool. So there's a couple of different ways in which you can create an app for the Google Assistant. So there's the one way which we call actions on Google, which allow you to create your own chatbot. Okay, so you would say, okay, Google, talk to the assistant or the custom assistant. And then you would sort of go into your own custom assistant code, and you would then do the conversation and manage the whole conversation yourself. Okay, so there's that one way. But this way that we're doing this thing now is by using what we call smart home or smart home graph. Okay, so with the Google Assistant, there's the concept of a home graph and a smart app that you build. And looking online, you won't find much information around these two sort of terms. So hopefully this will guide you in the right direction as to how to do it. So basically, when you're building for the smart home, you get what we call, and the Google Assistant manages a home graph, which basically looks at your house as a whole and contains information about your house. Okay? And inside your home graph, you would have different things such as a concept of a room. Okay, so I could have something like a bedroom, a living room, a kitchen, and all of this information then pertains as to what we would then store information around what exact sensors or different smart devices are inside those specific rooms. Okay, so for example, in my bedroom, I've got 2 lights and maybe a smart lock. Okay, so the Google Assistant will then build up this sort of knowledge graph of information about what is exactly in your house. So then, if I say, for instance, in my living room, I say, okay, Google, goodbye, I could configure it to know, turn off everything in my living room. So if I have a Philips Hue smart light, but I also have some other kind of smart lights, the Google Home will know everything in this room needs to be turned off. Okay? So it kind of manages this home graph state without you doing too much effort of that. But if you wanted to build your own app and integrate it into, say for instance, be a smart motion sensing camera, you would need to provide Google with information as to what exactly your camera can do and what exactly your camera, what state it has, so what options you can do on it. Okay, so it's quite cumbersome to create the smart home app, but hopefully a couple of diagrams later you'll be able to sort of grasp how the whole thing works. So the first thing that you have to do in order to do smart home apps is to set up an OAuth server for account linking, okay? Now if you follow the sample online, you can sort of circumvent this and just make like a dummy OAuth 2 server, just at least for testing purposes to get it to the state where you are able to actually control your device. But the first step would generally be to create this OAuth 2 server. The next thing that you need to do is create actions on Google developer project. So this would just mean going to the console, the Google console, and configuring this actions part. And then the action package that you create and upload onto Google servers declares support for this home graph or smart home intent, okay? Which is a little bit different if you've worked with the actions on Google, because you're now just defining a set of instructions instead of controlling the whole assistant behavior. Okay, and then the next step is that you would need to provide fulfillment for the smart home intents. So this means if Google then queries my service, I need to be able to say, for this user, these are the list of smart devices. In our case, these are the list of motion alarms for this specific user, so that Google can then take that information and then manage it themselves. The next step, once you've done that and handled all those intents, is that you would need to submit your app for approval to Google. So I think this part is probably where they're going to start asking you for hardware and say, like, we need to actually test that your hardware is working properly with our smart home system. Okay, so this diagram just indicates, and this one is on the actual official documentation if you have a look, but the blue parts of this diagram indicate what Google controls, and the yellow parts is what you would have to do as an end developer in order to enable it. So the first thing that you would need to do is provide the setup of where exactly your app is going to run, okay? So that is your web view setup, and they would need to be able to log in there, okay? So this will then give you your users that once they've logged in, you can then provide some kind of terms and conditions acceptance if you want. But once they've logged in, these OAuth credentials would then be passed back to the assistant app, okay? So the Android or iOS assistant app. Once your user has authenticated and provided the information back to the assistant will then take this information and it'll try to query your services using these credentials. So it'll run what we call a sync intent. And at this point, you would need to say to your users, okay, this user's come in with these credentials. What is their home graph or whatever? What is their information about this product that we need to know about? So that's where you would then provide, okay, this user has a motion alarm in their bedroom, or there is this device, here is what you need to know. The device is on, the device is off, all the different traits and characteristics that the device needs. Okay, so once they've got the whole setup and the sync going, there is what we call the execute command. So this is when I say to my Google Home, okay Google, turn off the bedroom lights, or okay Google, turn on the motion alarm. So the nice part about this is that Google manages the complexity of the speech recognition, the room and the natural language processing of this whole interaction, okay? So say for instance you set, hey Google, make the lights brighter, okay? It'll then create, it's aware of the home graph itself, so it knows exactly what to execute on your device. So it'll know it needs to up the brightness by a certain percentage. So once it's done that and done all the natural language processing, it checks which service it needs to query. So once it'll then decide, okay, I need to go to this service, which is, in this case, the yellow partner cloud services, and it'll execute the certain action on your service. So you don't need to worry about handling how the user said something. You just get a simple request to your service. And then you would execute it. So you would, for instance, I don't know, somehow turn it on maybe using Firebase, or we'll look into a few options in a minute. But you would use this and then execute and tell Google, OK, we've turned the lights on. OK. So a lot of the complexity of natural language processing is done by Google, but there's a couple of steps you need to set up on your device itself. Then there's also the state of query. So if I say to my Google device, hey Google, are the bedroom lights on? This is when Google would execute another query on my service to say, what is the state of this device? So is it on or is it off? And then I would just need to reply with the state, and then Google can say, your bedroom lights are on. OK, so you would just need to manage a lot of the sort of accessing the device that is the correct person accessing the correct device. But the large portion of natural language processing and the complexity of that is handled for you by Google. OK, so I'm just going to give you a quick demonstration of how the motion sensing alarm that I built works. And this one is using Android things, the Google Assistant, and Firebase as well. So it's just see if we can play a quick video for this.
This is a demonstration of the motion sensing camera powered by Android things. This yellow LED indicator indicates when motion has been detected by this motion sensor, and this red LED indicator indicates when the system is armed or not. And by armed, it means it's taking photos every time motion occurs and sending them to my phone, and a notification will appear if motion is detected. I can arm and disarm the system using the Google Assistant. OK Google, turn on the motion alarm.
You got it. Turning on the motion alarm.
You can see it's armed in the app as well as in the red LED indicator. As soon as motion is detected, the image is uploaded and I get an intruder notification that some motion has been detected with my system. I can also disarm it using the Google Home as well. OK Google, turn off the motion alarm.
Okay, turning the motion alarm off.
Then I will no longer get notifications, as well as the images will stop being uploaded to the system.
Cool. So that's a small example of what you can do using Android things and the Google Assistant. So if you want a little bit more information about this, you can head to the Actions package or Actions Google. So that gives you the Google Assistant example, including all the basic interactions of how to do the sync commands and the server-side setup for actions on Google. And if you want to access that Hackster project that I just demonstrated, the motion sensing alarm, there is the link for that. OK, cool. All right, so let's have a look at a couple of different options that you can do in terms of storage and communication for Android things. So the first and probably the easiest option is to use Firebase. So Firebase is Google's offering for mobile devices, but it also works really well for IoT and Android things. So there's two options that you can look at when looking at Android or Firebase storage or Firebase real-time sort of data storage. And the first one is the real-time database. So this is what I've used in that previous project that we saw. But basically, that allows you to get real-time access and notifications to your end devices without too much trouble. And you can store information there and query it quite easily. But quite recently, at a couple of months ago, Google Cloud, or Firebase Cloud Firestore, I'm always going to screw this name up, but the Firebase Cloud Firestore is the sort of next step on the real-time database. So this allows you to do a little bit more querying, and it's a lot easier to do certain things that you might have battled with when using Firebase. One thing to note is that it is in beta, though. So yes, like I mentioned, you get advanced querying on Firebase Cloud Firestore, and it's the next generation in terms of looking at Firebase real-time storage. So I would suggest, if you're going forward, building with Cloud Firestore, but you can also look at real-time database for the meantime, but it kind of provides you with two different sort of things. Okay, so quickly, looking at how we can store something using Firebase using our application. So in this example, I've just created a data class using Kotlin. And now I've just got two values. So I've got a name and a surname. So this is for some kind of dummy user that I'd like to store. And all you would need to do to store this information is say Firebase database.getInstance and get a reference to a certain point in your JSON tree that you would like to store this information on. And once you've got a reference to where you're going to store this information, you can then just set a value on that and it'll automatically save it to the Firebase database. So the nice part about this is if you've got anything else listening, so you've got a client, another Android app or something like that listening at the same point in my node, I can get a real-time notification update to say this data has changed and we can now use it or do something with this new data. So the automatic push notifications, I don't have to poll my server anymore when I use Firebase. Okay, so Cloud Firestore also looks pretty similar to store information, but there's now the concept of collections. So instead of just storing something to a certain reference, we have collections that we create within Firebase. I'm not going to go into too much detail around this, but you can have a look at how similar it is to the previous Firebase real-time database. Okay, so I wanted to touch briefly on what Google has released called Google Cloud IoT Core. So this is also in beta still, but it's a public beta, and you can get access to it just by signing up and trying it out. And what Cloud IoT Core offers you is two different things. So the first thing is a device manager. So this allows you to register and securely state which devices belong and can use your services. So it creates this sort of secure communication between the two, between your devices and your server. And it allows you to register these devices and make sure that they are communicating with the correct server. And then if you've done any sort of IoT programming before, you might have run into using what we call MQTT, which is a protocol that you can use to communicate with your devices. And it's quite a lightweight protocol to do this. So the Cloud IoT Core offers this protocol bridge, which you can use and connect your devices using MQTT to the server. But you can also get just as normal HTTP access as well. So if you wanted to just do standard stuff, you can do that as well. So what does this exactly give you, the protocol bridge? Basically, when you're pushing using MQTT to the server, it'll basically take your information and publish it to PubSub. So from this point on, all your information is in Google Cloud PubSub, okay? And I've got another really complicated picture, but this one is taken from the Google documentation. So this Cloud IoT Core, basically this diagram is just indicating how you can use it to store device config, so how your devices are being accessed. But then once information starts coming through Cloud IoT Core, you can see that is then published to Google Cloud PubSub, okay? And Cloud PubSub then is quite a powerful tool that you can subscribe to on a mobile app or on a website or via Cloud Function. And you can get that information in real time happening as your device's information changes. But once you've got your information in Cloud PubSub, you can then put it into anything else of Google, for instance. So you can put it into Cloud Dataflow and do some work on that. You can do some, store all your information in BigQuery and then do some analytics using Data Studio. So it's quite integrated into the Google Cloud platform from that point of view. Okay, so a quick example of how this might work in real life. So if I had a device, say for instance an Android Things device, and I was reporting some information. So my device was telling me the temperature. So it says, okay, it's actually quite cold now. So I'd publish that information to Google Cloud IoT Core, and that would then take it through to Google Cloud PubSub, okay? And then my PubSub, I can then subscribe on my server, my own standalone server, or on a Cloud Function, and I can get this information to say, okay, it is quite cold, so I need to do some logic with this. So I should probably turn on the heat, turn on the user's central heating in their house. So then what I would do from a server side is publish some more information to Google Cloud IoT Core, and then Cloud IoT Core would then publish that information to my Android Things device. So I would say use Cloud IoT Core for like very hardcore, lots of data you need to store, lots of very enterprise production information that you need to store, and maybe use sort of Firebase real-time database as an entry level. I need to store some data. I need to control exactly how something is turned on or off. But you can use them together as well. So you can control your device using Cloud IoT Core and store some information in Firebase and have Firebase control your device as well. So there's no one sort of solution fits all for this case, but you can use them in conjunction or standalone or not at all if you really don't like them. So like I said, you can also use your own solution if you want. So you don't have to use Firebase or Google Cloud IoT Core if you want. If you want to use some other provider or you've got your own backend, you can write that and use it on your own Android Things device. You don't have that limitation of you have to use this for Android Things. Okay, so that's a little bit on storage and communication. So I want to just quickly touch on a few examples of where Android Things has been done in the community and some cool things that you can have a look at. So the first one is the Edison Candle, and this one is built by Dave Smith, and he's the developer advocate at Google for IoT. And this example is basically just two LEDs that use some Android animations to control that it looks like a candle flickering, okay? So you might think, oh, that's so boring, why would I do something like that? So this example is a highlight of how you would go from idea into production with Android Things. So he takes you through the steps of creating the actual board once you've prototyped, and you now ship it into production. So that's, I think, where the big learning is in this example, is the actual process of how it works. The next one is what is called the BrailleBox. So I really like this solution from Joe Birch. And basically, this is a box with 6 different little solenoids that he's got, and it reads news from a certain endpoint, okay? And it reads them out and converts it into Braille. So you can just put your hand over it, and if you understand Braille, it'll start to change the different configurations into the different letters, which I thought was quite a good approach to using Android Things. The next one, which I thought was quite cool, is the AI Candy Dispenser. So this one is built by Alvaro Vibrans, and this one is quite cool. It's a game that you play, and it asks you to search for a certain thing. So it says, all right, find me a picture of a lion. And then you'd have to like scramble on your phone or somewhere and then show the lion picture to the device. And then using TensorFlow, it'll go and analyze the picture and say, yes, you got it correct, have some candy. So quite an impractical example, but it's very cool and lots of fun. There was another one by Paul Treblu. I can't say his surname, I'm just going to stop there. But this one's called a wildlife detector. So this one's also using TensorFlow, and he's taking photos. There was a whole backstory around this one. I can't really remember what it was now, but it was quite an interesting example of analyzing images and getting out different wildlife from these images. Okay, so why should you use Android Things? So the big reason for me and why I really like using it is because the power of Android. So I'm an Android developer by day. So for me, developing these apps is just really the next step for me in terms of development. I don't have to learn a new language or a new platform really. It's all Android from the start. And then I think the next big reason is that it's managed by Google. So security updates and just general shipping of the Linux kernel, that kind of thing doesn't really interest me, and I don't want to do it myself. So the fact that it's managed by Google is quite a nice feature of it. And then, like I mentioned before, the fact that it's automatic and secure. So I can get secure updates, rollouts, patches to any sort of issues in the Linux kernel that is handled for me by Android Things. Okay, so I really encourage you to go try and learn more about Android Things. So if you wouldn't want to learn more, you can head to the docs, the Android Things docs. There's a lot of good information there as well. And then there's a code lab. If you get access to a nice kit, you can access the Android Things code lab. So that has a lot of stuff about getting started and how to actually use Android Things. So thank you very much. I hope you go and use Android Things.
Thank you, Rebecca. We have some questions out here. What is the best way to go from Android Things to DevBoard to production hardware?
What is the best way?
What is the best way?
There they are. Okay, thank you. What is the best way to go? What is the best way to go from Android Things DevBoard to production hardware that you can sell? So I haven't done this myself yet, so I wouldn't be able to really talk about how to do it. But there is, like I mentioned, that Edison Candle example that shows you exactly what stuff you need in order to develop properly for it. So there's like a whole bunch of different metrics and stuff that you would need. But I would suggest, like, if you're like me and you don't have much experience in developing production hardware, find a company that does, and then use them and ask them how do we make all these different documents and everything that we need in order to build it. Cool.
The second question, are there any resources on the hardware part that you can recommend for beginners without electronics background?
Okay, so any resources on the hardware part that you can recommend for beginners without electronics? So I started out without much electronics background, so I encourage you to do the same. It's not that daunting, but there's a lot online. I think there's a whole, I can't exactly remember. I had an Arduino book. So there's a book that you get with Arduino kit that gives you a whole bunch of samples from first, like getting started with a certain protocol, and it goes into a lot more detail around how to build different samples using the Arduino. So it covers all things like such as power calculations and why you need resistors. So I think that was quite a good first step for me, was just using this Arduino getting started book. But yeah, there's quite a lot of information online if you just Google certain things. Like for instance, what is a breadboard? And you'll find a whole bunch of information online about that.
And last question, do you know any sensor for measuring the liquid without contact of liquid itself?
Okay. Okay. No, I actually don't know of any sensor like that. Sorry. I don't know if I can help with that one.
Thank you, Rebecca.
Cool.
If you want to talk with her personally, you can go to the speaker's corner, which is out here, and rate this session out here in the entry. Thank you. Thank you, Rebecca.
Cool.